Dear friends, Maths Aspirants is a collective of mathematics students, research scholars, and faculty members across India and abroad, initiated by myself in 2017. And we used to organize online problem solving sessions to help the students who prepare for different national level competitive examinations like IIT JAM, CSIR NET, NBHM, GATE, etc. As a part of that series, today we have a session on countable and uncountable sets, and we have Mr. Aviral Srivastava with us to engage the session. Mr. Aviral is currently pursuing PhD at IIT Gandhinagar. He did his MSc from University of Hyderabad, and he cleared many national level examinations like IIT JAM, CSIR NET JRF, GATE examination, and also recently NBHM Doctoral Fellowship in 2023. I'm sure that today's session will be really beneficial in your preparations for competitive examinations and also for brushing up the concepts that you have already studied in your degree classes. I welcome everyone to this program and wish you all a fruitful time ahead. Welcome, everyone.
So thank you, sir, for inviting me for the talk. And I'm very surprised to see a lot of people here, and I'm very little nervous to see, like, this is my first talk, so I don't know how will it go, but yeah. So we will be discussing basically some properties of the function, bijection, injection, and surjectivity. And using them, we will discuss a little more about uncountable and countable sets. Major focus will be on the problem solving, and through problem solving, I will also tell little bit concepts in between. Okay, so if you people have some doubt between the questions, you can ask, as well as if you feel that I am doing something wrong, or you can interrupt me, or you can point out. Okay, let's begin with the first problem. And I took these problems from some are from CSIR-UGC exam, some from TIFR, and some from that Madhava mathematical competition. Okay, I hope many of you must be familiar with that. Actually, IIT JAM don't ask much questions on countability. So I couldn't find much from there, but I selected simple problems as well as some challenging problems so that we can practice. Let's begin with the first problem. So what it says, hello?
Yes, you can continue, no problem.
So here's A is a non-empty subset of real numbers, and we defined a function f from A to A such that so we have this function f from A to A. And what is the property of the function? It says f of fx is actually equals to x. All right. What we are asked to we are asked if it is 1 1 on 2 or neither or both, right? So how we'll approach this problem? So first of all, we know the function, we know the definition of 1 1 functions, right? So a function is 1 1 if for every xy fx equals to fy imply x equals to y. Correct? So using this property, we'll try to do the 1 1. So suppose fx equals to fy. Okay. Then we can, since both are equivalent functions, of course, well defined, so we can apply f both sides. And by the property of the function, it is given that f of fx is equal to x. So f of fx equals to x and f of fy equals to y. So what we did, we started with fx equals to y fy, and we ended up proving x equals to y. So this implies function is at least 1, 1. So f is 1, 1. Correct? Okay. So for ontoness, can somebody tell me like what is the definition of onto? Anybody, just quickly.
Every element in the codomain has a pre-image.
Okay. So every element in a codomain have a pre-image in it. Or otherwise you can say that range of the function is equal to codomain, right? Okay. So let x belongs to A, okay, be some arbitrary element. Let me erase this. So if x is some arbitrary element of A, then we know that for any such arbitrary element, f of fx equals to x, right? What does that mean? It means that for every x belongs to A in codomain, we have fx, some element fx belongs to A, such that image of this fx is again equal to x. So since x is chosen arbitrarily, so we get that there is some element in the domain which map to x, hence it is onto also, right? Do anybody have doubt in this? Okay, I hope nobody has doubt. So it is 1, 1, and again it is onto also, correct? So it is both 1, 1 and onto, and first option is correct. Right? Let's move on to the next problem. Here is kind of, yeah.
So in this case, we can conclude that f is the inverse of itself.
F is the inverse of itself. Yeah, of course. F is the inverse of, yeah, and using that also you can actually say it is a bijective because it is inverted. Yeah. So, okay. So moving on to the next problem. It is some recursion relation on functions, and we need to find number of n's such that fn equals to 8. Okay. How it is defined? F of 2n equals to 2 of fn, and other relation is f of 2n plus 1 is equals to 4 times fn, right? So how can we find image of 8? First of all, we should observe that if I plug in n equals to 2 raised to k in this relation, then we will get f raised to 2 raised to k plus 1 is actually equals to 2 times f of 2 raised to k. Correct? Now,
Yes.
again utilizing the same formula, I can write it is nothing but 2 times f of raised to 2 raised to k minus 1. Correct? Similarly, going on, this term will be nothing but equals to 2 raised to k and f of 2 raised to k plus 1 and f of 1. Everybody agree?
Yes.
Right?
Yes.
Yeah. So f1 is 1. So we got, since f1 is 1 given, so 2k plus 1. 2k plus 1 is equals to 2 raised to k plus 1. Correct? From here, if I plug in k equals to k equals to 2, then you will get f of 8 equals to 8, right?
Yes.
Yeah. So n equals to 8 is one of the solutions. That's for sure, right? And let us utilize uh, other recursion relation to do this. Okay. So what is other relation given? Other relation is, so if tell me one thing, if I plug in from here, you can easily see that f of 2 equals to 2, right? If I plug in n equals to 1.
Yes.
Yeah. So if I plug in 2 here, I will get 5 and 4 times f of 2, right? Correct?
Yes.
Yeah. So f2 is given as 2. Since we got f2 as 2, so it will also again become 8. So another n which satisfy this is n equals to 5. All right. So at least 2 solutions we have. Now, let's move on and let's see some other solutions if we are able to find or not. So yeah. So if I plug in, suppose I plug in one more thing we can do. These are the 2 solutions, and one more thing we can do is that if I plug in fn equals to 2 in both the formulas, fn equals to 8 in both the formulas, we'll get f of 2n equals to 16 and f of 2n plus 1 equals to 32, right? So if I can point out for which n these relations will follow, we are done, right? So if you see carefully, first one is, for the first case, if I plug in n equals to 8, it will follow, right? Because it will be f16, and we know that f of 2 raised to k plus 1 equals to 2 raised to k plus 1, right? And it is of this kind, so it will follow. But the point is, n equals to 8 is already a solution here, right? One more thing we see, if f of 2n plus 1 equals to 32. Can we have some n such that this follow? Okay, we'll again see. So to get this, I plugged in. So to get this, let's see this model relation. Again, it will give us just a second. I think some mistake I did. Yeah. So again, if I plug in, suppose we got that f5 equals to 8, right? f5 equals to 8. We already have this, and from there, if I plug in f10, what will be the f10? F10 will be 16, right? Do everybody agree? If I plug in n equals to 5 here, it will be 16, right? Correct or not?
Yes, sir.
Yeah. So again, you see this, then f of, from the same relation, I can get f of 20 equals to 32, right? Now see, since this is odd and this term is even, so for no such n, this will follow, right or not? Because for no such n, it could be even number, right? Is there any doubt? Wait. Everybody is getting that? I found F5 equals to 8, right? Then using the first module relation, I got F10 equals to 16, and then using again the same relation, I got F20 equals to 32, right? But we wanted n such that this condition follow. But if you compare these things, then you will get n which do not belongs to n, right? Natural numbers, because this n will be some 9.5, right? So there will be no more solution. There will be only 2 solutions for this. Is there any doubt?
Sir, will that conclusively imply that there exists no positive integer other than 8 and 5, such that
Yeah,
f of n is equal to 8?
Yeah. What I did actually. So n equals to 8 and n equals to 5 already we got the solution, right?
Yes.
Right or not? Okay. So what I did, if there are some more solutions, other than these minimum numbers, then these since see f of 2n and f of 2n plus 1, these all are greater than n, right? I mean 2n and 2n plus 1 is greater than n, right? So actually I wanted to see if some number which is greater than 8 and greater than 5 also satisfy this or not, right? So what I did, I plugged in fn equals to 8 and see if other way it is coming, if some solution exists or not. So there will be no solution because one we already got here, right? The same because if I try to solve this equation, then this solution is common in both sides, and other one if you try to see, then it will get it will get to contradiction that n is not a integer. Okay, wait. Let me move on to the next question. I will explain in the last part. Okay, before like we vanish a lot of time in that. Is it fine?
Okay,
Yeah.
okay, sir.
So next problem. What it says, suppose A equals to a 4-element set and B is equals to 3-element set, sum 1 to 3. So we wanted to know number of functions from A to B such that exactly one element in B has 2 pre-images. Okay. What does that mean? We wanted a function
Means the
from
number of surjections.
B. What? Can you repeat?
Sir, it means the number of surjections from A to B.
No. What it require? Read carefully. That exactly one element in B has 2 pre-images in A, right? So what it require? It may not be the it may not be the surjection, right? So for instance,
Sir, since A has 4 elements, it should be the number of surjections. A has 4 elements and B has 3 elements.
yeah.
So
Okay.
if one element in B has a 2 pre-images, then it should be an surjection.
Okay. So it is saying that, okay, let me also figure out then. It is saying that a single element, we want to know all the functions so that exactly one of the element has 2 pre-images, right? Yeah, okay, exactly, yeah. So, so you can say it is a surjection because rest of the 2 will so rest of the 2 have to map 1 because they are saying exactly one element in B has 2 pre-images, right? Yeah, so it will be number of surjection also. So what is the formula for number of surjections? Actually, I thought to do it in some other sense. I have not thought in that direction. So yeah, you can utilize number of surjection formula also. What is the other idea? Other idea is, first of all, we need to choose one of the 3 elements that will have the pre-image. Okay. So how we can choose 3C1, correct? Correct or not?
Yes, sir.
Right? Okay. And first, now we have, since we have picked one of the element which will have exactly two pre-image, now we have to choose which of the two will be the pre-image of that element. And idea to select that is 4C2. Right? Correct or not?
Yes, sir.
Okay. So what we did, we we choose one element from here, then we try to choose two elements from here. Correct?
Yes, sir.
Yeah.
Yes.
And we need to multiply 2 factorial also. I mean, we need to multiply 2 also. Why? What is missing here? Because we have choose
can be mapped to 3 and add
exactly.
to both 1 to 3.
Yeah.
And
So for this 2, we have two choices: 3 or D, C or D, right? So that will also be count, and we have to multiply 2 because this 2 has two possibilities to map, and other one will map automatically then, right? Correct?
Yes, sir.
Yeah. So let's calculate this. It will become 3 factorial over 2 factorial times 1 factorial times 4 factorial point 2 factorial times 2 factorial. And let's calculate it. I guess it should be 3 times 6 times 2. It is 36. And as mentioned by some of you, it is nothing but actually number of surjections. So you can utilize surjection formula also to find the number of functions. Okay, let's move on to this.
Sir, excuse me.
Yeah.
Sir, can you repeat how you have taken the combinations?
Okay. I'm repeating. Let me remove all this. This 1, 2, 3. What is the question? It's saying that exactly one element in V has two pre-images in A. Okay. So we have to choose that one element first out of 3 which will have two pre-images, right?
Yes.
So first combination is 3C1 because we want to choose one element out of these 3 which will have the pre-image. Okay. Now suppose I selected 3. Then it have to have two pre-image. So how many choices are there? Out of 4, I have to choose 2 of them, right? So there will be 4 C2 choices.
Yes.
Okay. Now since we have selected the pre-images, the rest of the 2 elements, suppose 1 and 2 are left. Okay. Rest of the 2 elements, this 1 will have 2 choices. Suppose A and B. It can be mapped to A, it can be mapped to B if we assume that C and D are already taken by 3. So 1 has 2 possibilities. So I multiplied this. Okay.
Yes.
Is it clear now? So answer is 36. Okay, let's move on. This is set of all 2 cross 2 matrices over Z2 with set of integers modulo 2. And we have the function from this M to Z2 to M to Z2 given by fx equals to x square. Okay. We need to figure out if this function is injective, bijective, or whatever. Do somebody have some idea? Anybody have idea, or should I begin? Okay, let me begin. So idea is actually I didn't want to involve this problem because it requires a little bit of knowledge of matrices, but still I hope most of you must have important matrix, right? So if 2 cross 2 nilpotent matrices is there, so if n is 2 cross 2 nilpotent matrix, then we know that n square will be equal to 0. This is a well-known result in matrix analysis. So we will utilize this. So idea is we can get 2 nilpotent matrices which will do our work. First take 0 0 1 0. Okay. Take it as A and take other matrix B as 0 1 0 0. You can clearly see that they are nilpotent. Are they? Because of course they are all eigenvalues are 0, upper triangular and lower triangular matrix, right? So they are nilpotent, and so it means that f of A equals to A square, which is 0, and f of B equals to B square, which is again 0. Correct?
Yep.
This imply the function is not 1 1, right? Because fa equals to fb equals to 0 matrix, but it do not imply A equals to B, because A and B are distinct matrices. So it is not 1 1. Is it clear?
Yes, sir.
For surjectivity, okay, let me tell you that it is also not surjective. Can somebody now give me a count example? Anybody? Actually, there is something notion of a square root in matrix analysis, but we'll not go much into that. So let me give you one count example that I've created. So take a matrix 0 0 and same matrix actually. We will see that this matrix has no pre-image. Okay, this matrix has no pre-image. So take suppose A equals to ABCD, where of course ABCD belongs to Z2. Then what will happen? What will the A square? Yeah, yeah. So it will become A square plus
CB
and
AC plus BD, CD.
and other one
BA plus DB
Plus DB.
and BC plus DC, DD.
BC plus
This
And it is equals to
BC plus D square.
It's BC plus D square.
BC plus D square. Uh, 0, 0, 0, 1. Okay. Let's see if it has a square root or not. So if it is equals to this, actually I thought something else and no. Okay. So a square plus cv equals to 0. Let's see this. Otherwise, I will try to do something else. I thought it will become a square plus c square, but it didn't happen that way. So a plus d equals to 1, and then b times a plus d equals to b times a plus d is equals to 0, and other equation will be bc plus d square equals to 0, right? What we can conclude from here, first of all, either b or a plus d equals to 0, right? So let me write from here. I can get either b equals to 0 or a plus d equals to 0, right? But from this equation, it implies that a plus d can't be equal to 0, right?
Yes.
So it implies that b have to be equal to 0. Got it? Now again, since b equals this b equals to 0, from this equation, it implies that a equals to 0. Correct?
Yes.
Yeah. Now from this equation also, it implies that d equals to 0. Right? Correct? Because
Yes.
b equals to 0 if I plug in d equals to 0. And if d equals to 0, if d equals to 0, and what we left with? C. Right? So what we can conclude for C?
Yes.
Yeah. So then what will happen? This equation will be contradicted, right?
Yes, sir.
This equation
No,
will be
no.
contradicted because
Why, sir? As b equal to 0 and c equal to 1, this equation will not be contradicted, sir.
sir, a and d is came as 0. See, a and d are 0, right?
Yes.
So if what will be a plus d? A plus d will be 0, right? So c times 0 equals to 1. It implies 0 equals to 1, which is not possible, right?
Yes.
Yeah. So this is why it implies that this equation do not have a pre-image, because we got the contradiction on the values, right? So this is one example that that do not have a pre-image. So it is neither injective nor. Is this clear?
Sir, restricted characteristic of field is to how to be 0, like A0 and B0.
What? Can you repeat?
Characteristic objective state
Characteristic of
objective state
uh, can you please repeat again?
structure of field objective state.
Wait. Can somebody, if they understood, can somebody else say that? I mean, or you can write in chat. Characteristic of a field is a 2. Okay. So what are they saying? Where I multiplied by 2? Hello. Yeah, I got your point. What is like characteristic of a field is 0. So yeah, this is what I did, right?
Sir, he asked in the chart that how A B equal to 0 implies either A or B is 0. Yeah, it implies A or B is 0. Why not?
Yeah, I mean Z2 is a field, and I mean it follow the non-zero divisor property. Sorry, it do not have any non-zero divisor, right? Yeah.
Do not have a
So,
zero divisor.
okay. So it is a contradiction, of course, to the values of this. So neither injective nor surjective. Now, moving on to the next problem. If f is real valued differentiable function on AB, sir asked me to not involve continuity and differentiability, but I found this to be a decent problem, so I included. But there is no such high concept I will be utilizing there. So what is happening? F is a real valued differentiable on AB, and this f dash x is not equal to 0 for all x belongs to AB. What we require to prove is f is 1 1, right? Or I mean it is actually written as true false. So these all questions are from like 2-3 questions are true false from TIFR. So we will see them. So first is f is 1 1. Is there somebody have idea if it is 1 1 or something, or I mean, you can at least predict if it is 1 1 or not.
Sir, I think it is 1-1.
It will be
I
1
think
1,
it is
right?
not.
It will not be 1 1. Okay, two different opinions. Let's see. First of all, f dash is not equal to 0 for all x belongs to AB, right? And we want if f is 1 1. No. Now what I can do is that
So it should be 1 1 1, right?
it is 1 1. Yeah, it is 1 1. But how we will do? How somebody, if can somebody tell me how we will approach this?
So because the function is a different, the function says that it is differentiable on open interval a comma b, and f dash of
Yeah.
x is not equal to 0, which means
Yeah.
the function doesn't have any critical point on open interval a comma b.
Yeah.
So there doesn't have any maximum or minimum for that function, and hence
Alright.
there is no bending of this. So by horizontal line test,
Yeah.
we can conclude that it is 1 1.
Yeah, it is intuitively or geometrically correct, of course, correct reason. One more thing you can utilize is that I mean something called mean value theorem. How you utilize is as follows. So f dash is not equal to 0 by Darboux theorem. If you people must remember, by Darboux theorem, either f dash x is strictly greater than 0 or f dash x is strictly less than 0, right? Everybody
Yes.
agree?
Yes, yes,
Yeah.
yes.
Yes, sir.
So either it is greater than 0 or it is less than 0. So suppose let for some x comma y belongs to AB, fx equals to f by, but x not equals to y. What I'm saying, let x by and let, if f is not 1 1, then this condition will hold for some x by, right?
Yes, sir.
Yeah. So right?
Prime of x.
this by now using that mean value theorem, we will have some f dash alpha where alpha.
Alpha lies between X and Y.
Yeah, you can actually in without loss of generality, you can assume y is greater than x or something, right? So f dash alpha is equals to 0 for some alpha in the interval, but it is a contradiction to the fact that either it could be strictly positive or it could be strictly negative, right? So that's it. Okay, so it is true. By the way, all of who have answered, it is 1 1, so it is 1. So we utilize Darbox theorem and mean value theorem to prove it. Also, the geometrical idea somebody was giving, it will have a peak or not, that was also correct. Okay, so let's move on to the next problem. This is a very interesting problem. So it says if there exists a bijection between R square and open interval 0 and 1, right? So again, I would like to see the opinion quickly. If somebody have, is it true or false? True. Okay. Yeah. So one can predict it since the cardinalities are both cardinalities are uncountable, so they may be the bijection. So to prove this, first we know that there is a bijection from R to 0 1. Can somebody tell me what will be the? Okay, let me define only. So define fx equals to suppose e raised to x. Okay, this will be the bijection from R to 0 1. Okay. Now define g x comma y equals to f of x comma f of y. It will be again the bijection from R square to 0 comma 1 whole square. Correct?
Yes.
So if we manage to define a bijection from H, or even we manage to show there exists one such bijection from 0 comma 1 whole square to 0 1, then we will be able to say it is true, right? Otherwise it will be false. So to show that there exists a bijection, let's utilize that theorem, Bernstein theorem. Do somebody have it in mind? Bernstein's theorem? Okay, let me tell you. So it says if there is injection from A to B and I injection from B to A, then it says there will be a bijection from B to A, or B to A will have the same cardinality. It says. All right.
Yes.
Correct?
Yes.
Yeah. So
Yes, sir, yes,
first let me draw a bijection from 0 1 to 0 1 whole square. So let me define G. Not G. G I already took. So let me define phi from 0 comma 1 to 0 comma 1 whole square, and let us define it as phi x equals to x comma half. It will be injection, right? No problem. It will not be bijective, of course. Sorry, it won't be surjective, of course, but it is injective, right?
yes, sir.
Yeah. Now define other injection as H, and here's a little trick that we can utilize. So first, let me assume since we know that there can be two decimal expansions for a single number. For instance, 0.3 can be also written as 0.99999, right? Right? Everybody agree, right?
Yes. Yes. Yes.
So I am just making a convention that these 99 decimal expansion I will not consider. Okay. But like both are equal, so we can choose one of them, right? So what I'm doing,
Yes, sir.
I'm making a convention that I will choose one of them, and now using that convention, I'm defining the following. H of x comma y equals to 0.x1 by 1, x2 by 2, x3 by 3. And where nothing, this x1, x2 is nothing but expansion of this x, and it is nothing but expansion of this. It is a 1-1 function, and I leave it as an exercise for you. Hopefully, we'll be able to do it. Not very tough task to do. So h is a 1-1 function. You see. So we have drawn a 1-1 function from 0,1 cross 0,1 to 0,1, and 1 phi injection from 0,1 to 0,1 cross 0,1. And since both are injections, so by Bernstein lemma, there will be some function from this to this, which will be a bijection, right? Correct?
Yes.
Since
Yes, sir.
there will be a bijection, and we already have drawn the bijection G, so that composition of both the bijection will give us the bijection from R square to the 1. And hence this is true. Is there any doubt? Anybody has?
Sir, instead of constructing H as you given, can we consider the function the projection map H of xy equal to x? It will also be in one-to-one map.
H of in which case second one, right?
Yeah, the H function constructed. H of xy equal to x. Can we take like that? It will also be an injective map.
H of x by equals to no. It will not be, I guess, injective map, because x comma z will be also equal to x, right? Right?
Yeah.
Yeah. So it won't be a one. Okay. Whatever. So let's move on to this problem, and it says the set says that fx belong to the polynomial ring Rx, and fn belongs to z for all n belongs to z. Prove that it is uncountable or it is countable. It is true or false. So what is the prediction? These are the problems from TFR. So I mean, they were not very tough, but still have some work to do. Can anybody tell? Okay, let me tell. So what I claim is that if fn belongs to z, then coefficient f have to be the rational number. Everybody or somebody agree with me?
Yes.
Yeah, very nice. Somebody is agree at least. Why? Why should happen? Actually, the one of the reason that I gave is utilizing Van der Waals matrix. right? You must have heard of it, right? I'm sorry, I'm very bad at pronunciations, but whatever. So matrix of the kind x raised to x, x raised to n minus 1, that is 1, right? So matrix of this kind is known as Wander matrix, right?
Yes, sir.
Do you? Yeah, you people know, right? So what we can do, and we know that it is invertible if its entries are distinct. We also know it. If its entries are distinct, then it is invertible. So suppose for instance a 4-degree polynomial. I'm just taking for instance, okay? Suppose this is one polynomial which satisfies the property that Fn belongs to Z for all n belong to Z. Okay. Then what we will say, then let us define F1. Okay. Sorry, I don't have enough space. Let me but state. So let me define F1 equals to N1, F2 equals to N2, that is F5 equals to N5. Okay. And if we see carefully, then we can have a matrix, right? Then 1, 2, 2 square, 2 cube, 2 raised to 4, and that is 1, 5, 5 square, 5 cube, 5 raised to 4, right? Correct or not? And I can multiply these coefficients. I am forming the actually equations. So and this will be equal to n1, n2, n3, n5. Correct? Everybody agree that these equations will take the form this in the matrix form.
Yes, sir.
Yeah. So what we can do, since this entries of this Wander matrix are distinct, that 1, 2, 3, 4, 5 are distinct. So you can take the inverse, and you know that inverse of a matrix with integer entries, again a matrix with a rational entries, because we have to divide by that determinant also. Whatever, so I can actually write these as the inverse of this matrix, and times this vector, and you see this is visible to you all, like I mean just little bit in the corner. Is it visible what I'm writing?
Yes, sir. Visible.
So we can conclude that these coefficients will be rational. Okay. So this is 4 polynomial I have took with the similar methodology. You can take any polynomial and utilize that. You will see that it have to be the with the I mean rational numbers, right? So because a polynomial with the rational number is nothing but qx, right? Or it will be the subset of qx, some subset of qx, right? So this set will be the subset of qx, and you know that qx is countable, so this is false. How many of you know that qx is countable? If somebody don't know, I can tell. There is no issue in that. Do there's somebody who don't know that? First of all, this set will nothing but the contained in qx, and this qx is countable because if you see carefully, it is nothing but polynomials are always of finite degree, So it will eventually can be viewed as set of all finite subsets of Q. And we know that set of all finite subsets of a countable set is again a countable set, right? Set of all finite subsets of a countable set is countable. So this will be the this thing will be countable. So this will be false. How many of you are agree with me?
Yes, sir. Correct, sir.
Okay, fine. Okay, let's do this problem. What it says, let S be all, let S be the all sequences having entries is either 0 or 1. Then what can you say about S? Is it countable or countable? You have to say true or false. I hope answer of this question known. It will be uncountable. Yeah.
False.
Same. Okay, so can somebody tell me what is the famous technique that we utilize to prove the uncountability of this?
Sir, when it is countable, then it have a bijection from n, but 0 is not in natural numbers, so can it be uncountable?
No, we can't argue like that.
So in fact, we can find a bijection from 0 to 0, 1 to set of all binary sequences.
Exactly. And other way also, very nice method by Cantor called Cantor diagonalization, right?
Yeah, we can use also.
Yeah, some of you must be aware of that. So we can utilize Cantor's diagonalization to prove that it is uncountable. And actually, the simplicity and elegance of that proof is very nice. If you people have not studied, then please go study the Cantor's diagonalization to prove the uncountability of this set. So it is false. Okay. Now this is very interesting problem. So the function is injective. What are the views? Will it be injective or not?
I think it is not, sir.
It is not. Why? Why it is not injective? Actually, I thought to use a very clever technique to prove it is not injective.
Sir, it is an odd degree polynomial.
Yeah.
Sir, both plus √3 and minus √3 have the same image 0.
No. But √3s are not in Z. They are not in domain, right?
Yes, sir, my mistake.
Yeah. So they are not in domain. So we can let that. Okay. Let's see one method. So one method is direct. First of all, what you do, you equate Fn equals to Fn. And I will not explain this method largely, but I will give you a proper hint. So if you see, then it will become 3n and it will become m cube minus 3. Okay. Just simplify and you will have take n minus m common. And minus 2, right? So if n not equals to m, imply n square plus m square plus mn equals to 3. Right? Now since m and n are integers, so this equation will have only finitely many solutions, right? Because if it is equals to 3, only very small number of integers would be able to satisfy this, right? Okay. So if you people are not agreeing with me, then what we can do is that yeah. So this 3 equals to mn plus m square plus n square is actually greater than equals to 3 mm, right? By using which property? Arithmetic geometric mean inequality. Okay, this will be greater than 3m, so it will imply mn is less than equals to 1. Do you agree? Hello.
Sir, how the step that came?
How this inequality came?
Yes.
Yeah. Okay. Let me tell you. So the point is we know that m square plus n square over 2 is greater than equals to root m square plus n square. You must have seen this somewhere.
Yes, sir. AMGM inequality.
Yeah, this is what I was saying. Arithmetic geometric mean inequality. So AMG inequality. So m square plus n square is actually greater than equals to 2m. So this whole term will be greater than equals to 3m. So 3 is greater than equals to 3mn, which in turn imply that mn is less than equals to 1. Now at least you can see that it will have only finitely many solutions, right? Given that n square plus m square plus mn equals to 3. So okay, whatever. I gave you the proper hint. You can see that only 1 comma 1.
Sir?
1 comma 1. Yeah.
Sir, from the first step, n cube minus 3n equal to m cube minus 3m, we can
Yeah.
take n common out from the left side and m common out from the right side.
Yeah.
Which will imply multiplying and dividing, we get n by m equal to n square minus 3 by m square minus 3. So if n equal to m means n square minus 3 by m square minus 3 should be equal to 1.
Just
Which implies n square equal to m square. But since it is from the set of integers, it need not be true for all such n. So we can conclude that this.
Are you saying this? Right? This is
Yes.
Yeah. And from here, what?
So if you need n equal to m, which implies which happens if and only if m square minus 3 by n square minus 3 equal to 1.
Yeah.
So
okay,
we can conclude that. Yes. Then we can proceed on.
So you are saying that. So if we assume that it is injective, then n will equals to m, then it will follow that m square minus 3. Okay. So then m square equals to n square, and then it will give the other side, right?
Yes, sir.
Okay. It could be one of the idea, but somebody was saying root 3, right? But I can do something very similar. Let's do it. It is a little clever idea to it that to show it has a multiple roots, but not multiple root in this sense, but some other sense. Just in a minute, I'm telling. So what you do, you add and subtract to both sides. Okay. And now see this factorization. Can somebody quickly do the factorization of this polynomial? One root will be 1.
N minus 2, n minus
1. It is 3 degree. 3 degree. Be careful. It is 3 degree. It will have 3 roots, right? So I think n minus 1 whole square times n minus 2. Can somebody check it once? Is it correct or not? Okay, leave it. I'm saying it is correct. Believe me at least. So n cube minus 3n equals to this. Okay. Now that idea that somebody was saying is can be used. How can be used? It imply that now fn equals to this. Now it implies that f of 1 is equals to minus 2 and f of 2 is also equals to minus 2, right? And hence it is not injective. This is also one of the idea that you can see that you can form a polynomial by adding and subtracting some number which have roots in integers. Okay. So it also implies it is not injective. So this is incorrect. Okay. Now I'm moving on. I think these two questions are similar. Okay, whatever. Let's do this problem. So first of all, tell me what is this xm? I mean, tell me what is this x? Will it be countable or uncountable? Somebody, I have already did this problem. 2 or 3
Yeah,
problems.
X is uncountable.
It is x. X is
Uncountable.
uncountable. Very, yeah, very good. So first of all, if x is uncountable, then of course this and these are options are incorrect. Right? Now, what about by? What about by?
I think Y is countable, sir.
By is countable, right? It is countable, but what is the argument that you will give?
Since it is for finitely many n.
One idea you can intuitively think as that it will be somewhat similar to the set of all finite subsets of n, right? Set of all finite subsets of n. Other rigorous method that we can utilize is as follows: construct the following set. Set of all sequences such that x of n equals to 0 if n is greater than 2. All right. This is what it means, right? If xn is equals to 1 for at most finitely many n's, then after a certain point there will be all zeros, right?
Sir, are we telling that both sets are same?
No. This is just uk I have defined. Just uk. It means that after some k, all will be 0. This k is fixed actually. This can't be equal to by, right? Rather,
Yes. So
rather this will be true.
so n less than k maybe also be 0. It can also be happen.
Yeah, it can be also 0. But what condition I am using? I will take only those sets that have 0 from k onwards. Are you getting my point or not? Yeah. So I will take only those sets that have 0 from k onwards. That's it. So are you people able to see that the union of this from k equals to 1 to infinity will be equals to y?
Yes, sir.
So Y will be a subset of this set, sir.
First of all, you can show that y will be a subset of this, right? And again, in the other direction also you can show that this union will be the subset of y also, right? Or if you're not comfortable, I can show that.
Yes.
Right. Okay. So union of this k equals to 1 to infinity, uk is equals to y. Now, uk is a finite set. Do anybody is there who is not agree with me that uk is a finite set? for a given k. And if somebody is agree, then can somebody tell me what will the number of elements in UK?
Can be at most k factorial.
Not even k factorial. Since we are taking elements from 0, 1, so
Oh
each
yeah, 0 from 1.
yeah. So each step has two choices. So it will
K
be
square.
2 raised to k, right? If I make the k columns, suppose there are k columns, each column will have two choices, right?
Yes, sir. Yes, sir.
So 2 raised to k will be the cardinality of this. And now we know that since finite sets are countable and countable union of countable set is countable, so by is countable, and we are done, and the option second is correct, right?
Yes.
Let's move on to the other question, but this question I will not do. First of all, everybody read this question, and you will, of course, realize that this question is somewhat similar to last one. Actually, the language is a little bit changed, but it is eventually same as the last one. See. Instead of all the zeros from some point, they are asking us to put all the yes's after some point. This is what they are trying to do. In the last problem, we have just put it all the zeros after some point onwards. In this case, we'll plug in yes's after some point onwards. Can you see this?
Yes,
Definition
sir. So
of
after
yes.
finitely many times, A
Yeah.
will be equal to yes.
Yeah. So almost the same procedure that we followed last time, and will be the counter. Okay. Let's move on to this problem. What it says that if a is equals to x square, such that x is 0, 1, and x cube says that 1 to 2, and we want to see if 1, 1 function and all there. So see the option. First is that there is no 1, 1 onto function from a to b taking rational to rationals. There is no 1, 1 onto function from a to b taking rationals to rationals. Okay.
Yes, sir.
It is false. How can you say that?
Yes, false.
How can you say that?
Uh,
Okay.
Actually,
Let,
here J is
let's
an
let us take the consider the sets. So it is not very difficult to see actually. The set A is nothing but 0, 1, and set B is nothing but 1, 2, 8. Is there any doubt?
No, sir.
No, sir.
Now we want map between them, and you know that if I draw, let us go to some geometric idea. Okay? If I draw line from the point which map I mean such that 0, 1 map to 1, 8. Will it be fine? This is the coordinate I'm talking about, not interval. Oh, it is actually same. I'm sorry. Just a second. What I'm trying to do is the following. I am trying to map 0 to 1 and 1 to 8 to get a function. Okay. To do this, actually, how you draw a bijection from A to B and C to D? Tell me. How you do this?
No idea, sir.
No idea. Okay, fine. One idea is that take the map A to C and B to D. Okay. If you can map A to C and B to D, and for the sake of convenience, suppose there will be some continuous map, then by intermediate value property, it will be a bijection, right? So what I'm trying to point out is that take the point AC. Take the point AC and take some point BD. If I draw the map from AC to BD, if I try to connect the line from AC to A to A comma C to B comma D, then it will actually form wait, it was CD, so CD is from here to here, CD, and AB is from here. So if I draw this line, so see this, any point on this line, for instance this, okay, it is actually mapping to this point, right?
Yes,
Now
sir.
you can utilize this property. So what is the equation of line passing through 2 points? Y equals to mx plus c, right? Just plug in the points. They are these points are endpoints of the line. So just plug in the points. You will get c equals to ma. Okay, let's call it p. Okay, ma plus p. And again, if you plug in, then d will become mb plus p, right? Now you will get m equals to c minus d over a minus b, correct? And you plug in that point and you will get y equals to, I'm just trying to put a geometric idea that a line from one line between the 2 points can be seen as a bijection from open interval AB to open interval CD. So this is X, okay? And you can find out PS. How you can find out P? P you can find as B minus C minus D over A minus B times B, right? Okay. So if I plug in B, so if I plug in X equals to B, I will get Y equals to D, right? Right or not? And if I plug in X equals to A, then you can see that is A minus B cancel out, and it will give you this Y equals to C. You can plug in X equals to B and X equals to here, and you will in turn will get Y equals to D and Y equals to C. So this function basically is a mapping which is linear, so it is bijective, mapping from the open interval AB to open interval CD. I hope this idea is clear to everybody. I'm sorry for having a lot of weird kind of calculations, but it is a geometric idea that we go through. Okay.
Okay, sir.
Yeah. So using this, we can say that there will be one onto function from there to there, and option 1 is incorrect because coefficients of this equation, if you plug in that 0, 1, 1, 8 in the equation, coefficients of this thing will be rational coefficients, and it will map rational numbers to rational numbers only. So there will be such a map. So first one is incorrect, and of course we got 1 onto map, so CDR already incorrect, right? Okay. Now actually sir, like may I proceed for 10 more minutes, right?
Yeah, yes, Aviral. You can go for 10 more minutes.
Yeah. So actually, I selected, I guess, more questions rather than. So I will cover some important questions, leaving easy ones aside. For instance, this one is not very difficult. You have to see if it is 1, 1 and 1, 2. Okay. you can see this, and this is again we did several times. This 0, 1 is product, so this will become 0, 1 raised to n, and you know that it is nothing but set of all sequences in 0, 1, so you can utilize uncountability and countability, right? Or somebody have doubt? We did like lot of times this, right? Hello.
Yes, sir.
I
We
yeah,
did.
I hope.
No.
Yeah. So let me do some TFR problems because they are little tough than others, and one or two important problems, and I will wrap up that. Okay. So let's do this problem first. So they are asking how many maps from n union 0 and n union 0 are there with the property that phi of AB equals to phi of A plus phi of B. Okay. So can anybody have a quick guess? Okay. It is actually a very easy problem, not very tough if you realize. So first of all, if you plug in A equals to B equals to 0 in the function, you will get phi equals to 0 equals to phi 0 plus phi 0, which is in turn imply phi equals to 0, phi 0 equals to 0. Correct?
Yes, sir.
Right?
Yes, sir.
Yeah. Now what you do, plug in B equals to 0 in the equation. Then you will get phi times A times 0 equals to phi times A plus phi times 0. Okay. So phi times 0 is equals to phi times A plus phi times 0. Imply that phi times A equals to 0. And it is hold for every A because A was arbitrary. So it is nothing but constant function. It is 0 function. So how many such functions are there? Of course, countably many. Oh, sorry, not countably many, finitely many. Right? This problem was asked in TFR. First I saw it, then I thought it may be a difficult one to crack, but it was little easy. So we utilized just yeah.
Excuse me, sir.
Sir, can you please explain this once?
Yeah, of course. So first of all, by what we did, this is the equation that is satisfied by phi, right? So you plug in A equals to B equals to 0 in the equation. What we get if I plug in A equals to B equals to 0 in the equation, phi 0 equals to phi 0 plus phi 0, right?
Yes, sir.
Now since phi 0 equals to phi 0, by the cancelling property, you can cancel out and you will get phi 0 equals to 0. Correct?
Yeah.
No. Phi 0 equals to 0. Now you got this phi equals to, first of all, we got this, right? What the next step I did, I just plugged in B equals to 0 in this and keeping A as it is. Okay. So I'm keeping my A as it is and I just plugged in B equals to 0. It became A times 0, phi of A times 0 equals to phi of A plus phi of 0. Correct?
Yes, sir.
So phi of A equals to 0 because phi 0 is 0, phi 0 is 0, so phi of A equals to 0. A was arbitrary, so this should hold for all the A's. So only function that could satisfy this property is actually 0 function. I hope now it is clear. Right? Or still you have doubt?
Yes, sir.
Tell me.
This is we are taking from the whole number, right, sir? The
Yeah,
0
this
is
is
also included.
yeah, 0
Okay.
is also included. Yeah.
So whole number is countable.
But
So that will
we
conclude.
no. Wait. We wanted to know how many such maps will be there, right?
Okay, sir.
What was the problem? Problem was to see how many such a maps will be there. So after doing this calculation, we realized that phi a equals to 0 for a, all a belongs to whole number, right? It implies
Yes, sir.
that only zero map is such a map which is following this condition, right?
Yes, sir.
And we wanted to know how many such maps are there. We actually eventually ended up with only one map. So how many maps are there? Only one, which is finitely many, right?
Oh, okay, sir.
Yeah, we are not looking for if n union 0 is countable or not. We are looking for how many such maps are possible, right? Okay.
Yes, sir. Now I understand, sir. Thank you, sir.
This problem, do somebody have idea? Be little quick. We are running out of time.
No, sir, no idea.
Do you remember something called Cauchy-Schwarz inequality? I hope that famous inequality you must have heard. Okay, let me tell you. So what it says, Cauchy-Schwarz inequality says that summation I equals to 1 to n ai bi is less than or equals to root of summation ai whole square times root of summation bi whole square. Correct? This is the
Yes, sir.
Cauchy-Schwarz
Correct.
inequality. And if you take the square both sides, we will see this summation will be equals to, sorry, less than equals to summation ai whole square plus times summation bi. And in the same inequality, if you read the proof of the inequality, then the proof says this will be the inequality and the equality will hold. Okay, so for first of all, if I take suppose ai equals to fi, okay, and bi equals to 1 by 2i, right? So if I plug in here, we will get something like this that we have actually in the expression, right? Correct or not?
Yes, sir.
And actually that Cauchy-Schwarz inequality theorem says, when you will read the theorem, it says equality will hold. So equality in this case, equality in the equation 1 hold. If ai is nothing but some multiple of bi. So for multiple, let me utilize P of bi, where P belongs to R. Okay. So Cauchy-Schwarz inequality says that this inequality will hold if and only if ai is a multiple of bi. So now you see, if I take this thing as alpha upon 2i, okay, if I define this fi to be, let's remove out this alpha. So if I define fi as alpha times 2i, and if you plug in for any alpha belonging to r by 0, and if you plug in this fi there, this equality will hold. How many of you agree? Tell me. It is very obvious. It will obviously hold. Nothing much to see. Should I plug in? Okay, let me quickly plug in. So summation I equals to 1 to 10 alpha over 2i, sorry, alpha over 2 raised to I and this whole square is equals to summation I equals to 1 to 10 alpha square over 2 raised to I whole square and times summation I equals to 1 to 10, 1 upon 4i. Now see this, other than alpha square, both the terms are equal. I'm sorry for this little messy thing out there. Okay. So just I will say that if I take fi equals to alpha times 1 over 2i, if you plug in that fi there, very easy calculation, very trivial calculation will show that that this equality will hold. You can check very easily by plugging fi. Okay. Can somebody plug in quickly and tell? Actually, I have very less space to do it, but okay, let me do it. Yes. Summation I equals to 110 alpha over 2i instead of I and times 1 over 2i. This was the summation and whole square, and the other part was summation alpha over 2i whole square times summation 1 over 4i, right? This will become, and if you multiply this, it will become I equals to 1 to 10. I can multiply this 2 power I and it will become alpha 4 power I whole square, right? And other term, if you see, then if I take out alpha square, because alpha is constant, it will become, because of whole square, it will become 4 raised to I, and again it will become summation 1 by 4 raised to I, right? And it will again become summation I equals to 1 to 10 alpha over 4 raised to I whole square. I think now idea is clear, right? At least somebody say yes or no. I mean,
Yes, sir.
is it clear? Yeah. So because any fi such that alpha over 2i will satisfy this equation, where alpha belong to r by 0, so there can be uncountably many choices for such fi. So there will be uncountably many fi's which follow this property, because we can, for every alpha, you can pick the map fi equals to 2 over I. Okay. And map is from 1 to 10 to R, so it will also follow, because alpha belong to non-zero real number. So it will follow for all alpha non-zero, and hence it is uncountable. Do you agree?
Yes, sir.
You can see this map if it is surjective or not. So first of all, it is not surjective. This map is defined as 2 raised to m times 2m plus 1. See, first of all, see that 0 has no preimage. Okay. 0 has no preimage because 2 raised to m times 2n plus 1 is equal to 0. First of all, this is odd term. It can't be equal to 0 because 0 is an even number. And 2 raised to m cannot be equal to 0, right? For any m, being an exponential function or whatever the reason you can think of. So 0 has no preimage, so it is not surjective. And for bijectivity, I will leave you as an exercise for you. It is not a very hard exercise to do. So what you can do, take some m1 n1 and m2 n2 and equate them. And if suppose m1 and m2 are not equal, then 2m1 minus m2 times this odd integer is equals to odd integer. What I'm saying, if m1 equals to m2, then it will imply n1 equals to n2. Okay, then we are done. Then this will prove the injectivity. Otherwise, if m1 minus m2 is not equal to 0, then it will be greater than 0, because it is an integer. Call it k. So if we plug in k, then this quantity will become even, this quantity will become odd, but odd quantity cannot be equal to even quantity. So our assumption that M1 minus M2 is not equal to 0 is a contradiction. So it is 1, 1, but not surjective. So this option is true. Do anybody have doubt? I will explain. Do anybody have doubt?
No, sir.
Okay. Actually, I thought that I will be able to cover all the questions. So I took so many questions to do. Let me do this problem, the last problem, because we are already over the time. This is a question from TIFR, and it is very interesting problem. What it says, there exists a map from Z to 0 such that F is bijective and increasing, F is onto and decreasing, bijective and satisfy this, and has uncountable image. First of all, because map has a codomain Q, so it cannot have any subset which is uncountable, right? So D option is incorrect, because there is no uncountable set K which lie inside Q. Of course, right? Yeah. So D is already wrong. Why there can't be a bijective increasing function? There is a question I would like to ask you. Why there can't be a bijective increasing function from Z to Q? Can somebody answer very quickly, or otherwise I will answer? Okay, nobody.
For
So,
being but number of elements should be same in set and Q, but
no. Cardinality should be same, right? So cardinality of Z and Q are same, and in fact we know that there exists a bijective map from Z to Q.
okay, sir. Okay.
But the problem is in the increasing part. I will tell you why it can't be increasing. Suppose it is increasing. Suppose. Okay. Suppose F1 equals to P and F2 equals to Q. Then by the increasing property, this F1 should be less than equals to F2. Right? But in the interval PQ, there are infinitely many rational numbers left. Right? Right or not? Between PQ, there are infinitely many rational numbers. Now we map 1 to Q and 2 to Q, 1 to P and Q, 2 to Q. So the point is, these rational numbers cannot be mapped by any of the integers then. Right or not? Suppose if some n is less than n, and suppose alpha is there, some alpha in between, and suppose Fn equals to alpha, then it will contradict increasingness. Do you agree? It will contradict the increasingness, right?
Sir, repeat once.
Okay. N is less than 1. Okay, suppose n is less than 1. Then Fn is less than F1 because it is increasing.
Yes.
It will imply Fn is alpha. It will imply alpha is less than P. But we took alpha in between PQ, right? So we took alpha in between Q2, so alpha should be greater than P. But what we are getting? Alpha is less than P, which is a contradiction. So for any n less than 1, there can't be Fn equals to alpha. This is the first case. Suppose some n greater than 2, which map to alpha. Then what will happen? Then it will imply Fn is greater than F2 because it is increasing, right? Now since F2 is Q, so and Fn is alpha, so alpha should be greater than Q. But alpha is between P and Q, so alpha is less than Q. But what we are getting? Alpha is greater than Q. So no number either greater than 2 or less than 1 can map a rational number between PQ, right? And we are working in the integers. So we can only think of any integer which is greater than 2 or any integer which is less than 1. So in both the cases, any of those integers cannot map alpha. So it implies that such a map cannot be surjective. So it is not possible. Since we contradicted the surjection, similarly, it is decreasing. And again, we can use the same argument to show that the surjection cannot be there. The only option left is this. 42, it is 842. I really want to ask and everybody, have you got this problem? Or do we have any doubt? If somebody had doubt, I can explain, and this is the last problem that we are doing. I will send the PDF of this, and other problems you can try by yourself. Do anybody have doubt? Tell me first. Actually, I thought this problem is very, very nice problem to do, so I thought to include it. Is idea clear, or anybody have doubt?
So it's clear.
It is clear. Okay, so sir, should I stop? I'm sorry that I included a lot of problems. I thought that I will finish them, but like time. Yeah.
Thank you, Aviral, for this nice session with a good collection of problems from different examinations. I am sure that those who have seriously attended the session will definitely have obtained many good ideas in solving problems. Once again, thank you, Aviral. Now it is the time for feedback and to ask your queries. Feel free to share your feedback please keep your video on mode while you share your feedback, and please try to introduce yourself. Yes. Yes,
Sir,
sir.
I am Aditya Krishna. I am from Kerala, Palakkad district. Your class was so amazing and nice. I got many more ideas to solve the problems, and I have got many more questions from different entrance exams. So I hope you will take more classes. Thank you, sir.
Thank you for the compliments.
I'm Shikha. I've completed my integrated MSc in mathematics and computing. So your class was really nice. It was very interactive. You just given different approaches for attending one questions. It was really very nice, and there were many new concepts like Vandermonde matrix. It was nice to know, and yes, it was really very helpful. And thank you, Vinod sir, for organizing such sessions. Thank you.
Yeah, I would like to say thank you, Vinod sir, already, because nothing like it was not my idea. Thank you, sir, for like inviting me. It was very nice session.
I am Dharmendra Singh from Kasganj. The session was very nice, and problem also very nice, based upon function and bijective and one-to-one. Very deep concept was taken. Can you tell about some preparation of these type question and about NBHM exam and paper exam? What book and what problem book can be taken?
So the point is, I will, if you want advice kind of thing. So for NBHM and TIFR, basically try to rely on basic concepts first. Okay, so try to read books rather than reading somebody's notes. Try to read books line by line. Although it will take a little time, but I'm very sure that you will utilize, or you will see the concepts very deeply. Second thing is that there are a lot of exercises already given in the book. Try to solve those exercises. And for more like problem type book, you can see for real analysis. There's book by, oh, I forgot. Oh, I'm sorry. It was problems
Sir,
in
you can
real
write later
analysis.
in your notes. Yeah.
Yeah, I will tell the books, problem solving books. There are a lot of books, and try to I will advise one thing. Try to focus more on the ideas, how you utilize little concepts in the questions, rather than trying to by hearting the result or doing or something else. That's it.
Sir, sorry. Please share your email ID with your PDF also, so we can contact by mail if any problem. Thank you, sir.
Yeah,
Thank you very
sure.
much.
I will
Thank
share
you.
my.
Yeah, Aviral, you can share the names of the problem books along with your PDF. We can share it with the members. Okay, thank you. Thank you, Dharmendra. Yes, others?
Hello, am I audible?
Yes.
Hi, good evening. First of all, like you mentioned in the starting of the session, this is not a topic in which there are a lot of resources. So first of all, thank you for choosing this topic, Aviral sir and Vinod sir, both of you. My name is Lakshmi. I am from Hansraj College, University of Delhi. It was actually a really great session, and we got really new perspectives of how to take on problems. So thank you so much. Looking forward to having more sessions with you.
Yeah, thank you so much for the compliment. Yeah.
Thank you, Lakshmi. Yes, others? Dear members, feel free to share your feedback video on. No need to.
Sir, I'm Ananda.
Yes, yes,
Sir,
yes, Ananda. Yes.
Yes, sir. Thank you, sir, for this wonderful session, for introducing such interesting questions. And thank you, sir, for this wonderful session.
Thank you.
Yeah, thank you. Thank you, Ananda. Yes, Praveen, you can speak now. Yes, Praveen.
yes, sir. So first of all, thank you, sir, for this session. You had collected questions from a lot of different resources. So thank you a lot for one questions. Like as we had seen in the session, most of the questions are time consuming. So is there anything that we can do to save time?
You mean like time saving thing during session or otherwise? I mean, while you while you were solving or while session?
Yeah, I think he is asking about some easy tricks
Yeah,
for
sir. For the exam, like
Oh,
when we are solving these questions for
for
exam.
for the exam purpose, the point is till I have seen the first of all practice is mandatory. Once you practice 10 problems, 11th problem will automatically come to you. That kind of thing is there. Okay, so once you start first, when you will start with some topic, you will it will take little bit of time to do some problems. Then you will start picking the problems itself. That yeah, now here I have. So after solving 10 questions, you will have 10 different kind of tools in your hand. For 11th question, you have 10 tools you can throw on it. So that kind of thing is there, and it's all about practice that that will make you a little wise than others or little less time consuming. Yeah.
Yeah, that is really an important point. Remember that the only way to learn mathematics is to do mathematics. So do maximum number of problems, be familiar with more and more problems. Don't miss any chance for that. Then certainly you will be very easy. You will be very fluent to solve the problems in a quick time.
And one more thing that I would like to say, like if you sometime get the free time, suppose if you have some free time, just pick out any random question paper, TFR, NBHM or something. Just pick one problem and try to see how you will utilize the tools that you already have to do that problem. Suppose you are going somewhere on walking and just try to keep that problem in mind and try to think how I will utilize. And that exercise that you mental exercise that you do while walking or while doing some work, it always help you in the exam to tackle the new problem. So this is one thing that I would like to add.
Yes. Okay, others? Yes.
Hello, sir. Hello, sir. I am Fatma Muhammad Ali from Society College, Kannur, Kerala. Sir, so the topic was very interesting. The solvage of topic was interesting. Questions were interesting, sir. Thank you for the wonderful time. And even though I'm a bit slow learner, still I've catch up. I think I've catch up everything, sir. Thank you.
Oh, thank you.
Thank you, Fatima. Yes, others?
Hi,
Yes,
sir. I'm Zahra Rumaisa. Sir, it was really nice session. And thank you for teaching us a lot of interesting problems. And thank you, Vinod sir, for conducting this such a nice session.
Okay, thank you, Sahra.
Hello, sir.
Yes.
Hello, sir. I'm Riza from Kerala. Thank you very much, sir, for putting your time and effort on this session. All the problems were very well explained. Thank you very much, sir. Also, thank you, Vinod, sir.
Thank you, Riza. Yes, others? Yeah. Yes, Tilak?
Hello, sir. I'm Shyama
Yeah.
Kumar from Aspirants University, Bangalore. It was a really nice session with a lot of different kinds of problems. Thank you so much for the class, sir.
Thank you.
Yeah. Okay, thank you, Shyama. Yes, Tilak Arundhati. Yes, you can speak now.
Hi, sir. Thank you so much, sir, for conducting this great session. And I'm always thinking to solve questions in TA for NBHM is so difficult, and I don't know how to connect what concepts we learn and how to connect with that question and how to approach the questions to solve and but uh, after attending this session, I learned some ideas to approach the questions. Thank you, sir.
Yeah, Tilai, that is the point. The confidence in attend a problem. That is the important thing. Okay. No need to worry about whether it's possible to solve and all that, but you have to try. Okay, that is the important thing.
And the one thing is that whatever the exams are there in BHM and TFR, actually they ask a very basic problem. First of all, they may look at a first glance that they are not even touchable, but the fact is that when you will see those solutions or try to do the problem on your own, they just utilize little basic concept that you have learned in masters on BSc, and based upon that they make the question. So you have to just utilize those concepts, but that enough capability of utilizing those basic concepts in the problem will only arrive when you will attend more and more problems. So the practice is the key. That's it. Yeah.
My name is Vandana and I'm from Kerala. First of all, thank you for the session. The topics were very clear and understandable. Thank you for sharing your ideas and also for spending your valuable time with us. Thank you.
Thank you.
Thank you. Yes. Any others?
Good evening, sir.
Yeah.
My name is Gopalakrishnan. I'm from Kerala. I'm studying first M.Sc Mathematics in IIT College, Alappuzha. First of all, I need to thank Vinod sir for arranging a wonderful section. And also, this is my first class with the Maths Aspirant. And the class, it's so wonderful and amazing. Got new things, and thank you, sir.
Yeah, thank you.
Thank you, Gopalakrishnan. Yes. Okay, others?
Hello, sir.
Yes. Yeah, Akita, yes. Yes,
Hello,
sir.
sir. I am Magida from M.Sc College, Tirur. Today's class was very nice and interesting. Thank you, sir, for your valuable time with us, and thank you, Vinod, sir, for conducting this class.
Okay, thank you, Akita. Yes, Dharmendra, you can ask. Yeah, Shrija,
Yes,
yes.
sir.
Yes, yes, Dharmendra.
Yes, sir. I was asking some doubt in one question. Open interval 0, 1 square taken. What is mean by this? This is like a Cartesian product of sets.
Yeah.
Or
Actually, that square means the Cartesian product of the set by itself. So if I write A square, it means A times A cross A means the Cartesian product of A with itself. Yeah.
Yeah, it will be an open square without boundary.
Okay. Thank you, sir.
If you are using open intervals. Yes, Shrija Yadav.
Hello, sir. Good evening, sir. My name is Srija. I'm from BSc Data Science.
Yeah. Yes,
Your
Shrija.
class is so interesting, sir. But, sir, can you conduct any statistical classes, sir?
Yeah, Shrija, could you introduce yourself? You are from which place, which institute?
I'm from Hyderabad, sir. I'm from IIT College.
Sorry? Please.
In IIT College.
Okay. Some range issue is there, I think. Yeah, Shrija, we will try to arrange. Basically, our platform is more concentrating on maths. Yeah, of course, statistics is also a part of it. But yeah, we will try to make sessions from that area, possibly in future. Yeah, yes,
Okay,
any
sir.
others? Yeah, if any of you would like to share any opinion or comments, feedback, please do it now. Otherwise, we will.
Hello, sir.
Yeah, it's Lakshmi.
I am Lakshmi. I am from TMC College, Tirur, Kerala. Today's class was really interesting and informative. You explained each and every question clearly, and I got a clear idea about this topic. And thank you so much, sir, for spending your valuable time with us. And thank you, Vinod, sir, for conducting this class. Thank you.
Okay, thank
you,
you,
Lakshmi.
Yeah. Yeah, Chandana Sri. Okay. If any of you would like to express your comments, please do it. Okay, I think.
sir.
Yeah, yes. Anila. Yes.
Hi, sir. My name is Anila. I am from Kerala, Kannur. Thank you for conducting this wonderful section, and it was interesting. Thank you, Vinod, sir, for conducting such wonderful section.
Okay, thank
Thank
you,
you,
Anila.
Nila.
Yes. Okay, thank you, Aviral, for this nice session. And yeah, I think our members are really enjoyed the way you are presented the problems. And the one important thing is that you have done a really good homework to choose a good collection of problems, not so much trivial ones, but also, yeah, helping them to think more about the basic ideas. So I'm sure that today's session will be really very beneficial for any aspiring student who are seriously preparing for any competitive examination or who wish to understand the concepts well. So definitely your session is really, even though you are doing the first session in our platform, the session was really a very nice one. I'm very happy on that. I would like to once again express my thanks and gratitude to you for being with us in our Math Aspirants platform. Thank you, Aviral.
Yeah, thank you, sir, for giving me this opportunity to utilize my knowledge and share it with these aspirants, because some days back I was also there in the audience, and I was also learning the concepts in the same math aspirant group. So I'm really happy to be in the family and really enjoyed clearing the doubts and solving those problems with these people. Thank you so much for inviting me for the session. I'm really happy to.
Yeah, thank you, Aviral, for your nice words. These type of comments about math aspirants are really very motivating us to do more and more sessions and to arrange more problems for the students. Tomorrow we are planning to have a achievers meet. I hope that you will be there for tomorrow's session. We are arranging an achievers meet. So I welcome all the participants for tomorrow's session. Once again, thank you, Aviral. Please do share your PDF. If possible, please include some outlines for the problems that you didn't covered in the session.
Yes.
That will be useful for them. And please try to find out some more time to engage more sessions in our platform. I am sure that I know that you are in the busy schedules of your PhD. Still, whenever possible, please try to arrange some.
Yeah, whenever possible, I will try to conduct a session, and it is really a joy to learn with them because it is really a kind of a very fresh experience for me to again do those problems. And I also stuck, like when I was trying to do the solution, I also stuck in 1 and 2 problems. It was really kind of revising things by myself. So it was also a learning experience for me. Yeah. We will be doing more sessions.
Yeah, I think in today's session, some students have pointed out some different ways of doing problems in the So whenever people like-minded people come together and do some problems together, definitely it will be a great experience. Once again, thank you all. Let us wind up here. Okay, good night.
Thank you, sir. Thank you, everyone. Good night.